Alright, so here's the answer for the rest of the table. G of x is a quartic function, left-hand behavior. As x goes negative infinity, g of x is going to go up to positive infinity. Right-hand behavior, as x goes to positive infinity, g of x is going to go to positive infinity. It's going up, so both are going up and up. What are the zeros? I said approximately at negative 2.5 and approximately at 2. And how did I find the multiplicity? At negative 2.5, for me it looks like a line going straight through it, so I said multiplicity 1. At 2, however, do you see it looks like going up and then pause and then going up again? Or if you go to zoom in, it looks like a cubic graph around x equal 2. So I said that at x equal 2, it's going to have a multiplicity of 3. Did I see that? Hopefully you do. Alright, h of x, what about it? Left-hand behavior, negative infinity, right-hand behavior, positive infinity, 0, 0, 4 zeros, negative 4, negative 2, 2, and 5. What about multiplicity? All of them have multiplicity of 1 except at 2. I say that's going to have multiplicity 2. I'll show you why. If you look at x equal 2, look like a quadratic graph around it. That's why I said multiplicity 2. Okay? We talked about that. Talk about what actually multiplicity is. It is, make sure to write down, the number of times 0, x equal a is a root of the functions. Please write it down. The number of times 0, x equal a is a root of the function. So if it's a 0 once, multiplicity of 1. If it's a 0 twice, multiplicity of 2. If it's 0 3 times, multiplicity of 3, and so on. And the hint we used when we were looking at the graph on above was just see what happened at the 0 in terms of the shape of the graph. If it looked like a linear going through it, we said multiplicity 1. If it looks like a quadratic touching the 0, like that, we said it's going to be multiplicity 2. If it looks like a cubic function around the 0, we said it's a multiplicity of 3. And that's what these 3 statements are. You don't have to really read it. We already went over it. Okay, so underneath it, a few questions I ask. What do you notice about the sum of the multiplicity of the zeros and the degree of the function? Okay, so let me scroll up a little bit. When we found number of zeros and the degree, did this bother some of you? Some of you were like, oh, why is this bothering me? I don't know, it doesn't bother me. Well, like for example, quartic was 4th degree, and I only had 2 zeros. Quintic is 5th degree, and I only had 4 zeros. Well, if you remember what you learned in back in Algebra 1-2 days, your teacher might have told you that number of zeros are same as the degree of the function. And obviously, that is not true on this case. So you're like, I learned something wrong. No, you actually learned it right, except you didn't really learn about the multiplicity back then. But now that we learn multiplicity, all of that issues should be resolved. So let's look at that statement on that table. What do you notice about the sum of the multiplicity of zeros and degree of the function? And we're going to compare it. All right, first, let's look at the f of x. Cubic, what's the degree? 3. Okay, now let's find the sum of the multiplicity. That one has multiplicity 1, 1, 1. What is 1 plus 1 plus 1? 3. What do you notice about the degree 3 and the sum of multiplicity 3? That looks the same to me. All right, let's make sure that's keep going. Same way. Quartic is 4th degree. Sum of the multiplicity. Let's see, this one has multiplicity of 1. This one has multiplicity 3. 1 plus is 4. So do you see sum of the multiplicity 4 is same as the 4? They're the same. What about this one? My camera's a little slower. Sum of the multiplicity 1 plus 1 plus 2 plus 1 is 5, is same as a degree 5. So underneath it, we are going to say the same. And this is super important that you know what that means and be able to apply that. All right, next, describe the behavior of the graph. It approaches 0 whose multiplicity is 1. So like over here, at x equal -2, -1, and 1, at x equal -2.5, and all the ones with multiplicity 1, what did your graph look like? We'd say usually that it's just going to look like a linear graph around that 0. And we're going to write that a little fancy way. The graph crosses x-axis without changing concavity. Let's write it down. At multiplicity 1. So 2 examples possible. Goes going up this way or going down through the zeros. The graph crosses x-axis without changing concavity. Alright, what about multiplicity of 2? Please look at that example over here. The last graph at x equal 2. We saw that it looks like a quadratic function around it. So is it crossing the x-axis? No, but it's going to bounce back. So we're going to write the graph is tangent to the x-axis, touches but not crosses. And these are 2 possibilities. Alright, what about the multiplicity of 3? Which example should you look at? The middle one at x equal 2. What are we going to say? Well, did I even talk about multiplicity? Sorry. Alright. The graph is tangent to x-axis, meaning touches, but not crosses. At multiplicity 3, we're going to say the graph crosses x-axis and changes the concavity. For those who don't know what concavity means, concavity, you can think of it as like a U or upside down U. So this is concave up, this is concave down. If you look at this point right here, that was concave down, and then as soon as it touches the x 0, it's going to go back to concave up. So we are changing the concavity here. As well as around here, it was concave up to concave down. Okay, so write that down. And let's go to the back page. Next page, I shall say. Oh. Alright, for each of the following function, you're given a factor of the function. Identify the 0 associated with the given factor. Then use synthetic division to determine how many times the given factor is a factor of the function. Then identify the multiplicity of the root associated with the factor. So what are we given? We are given the cubic function, and you can see the graph underneath it. And it's asking you, is x plus 1 a factor? If it is, how many times? Well, does that look familiar? Will sound familiar to you? Yes. Why does that sound familiar to you? Because we learned exactly the same. We did exactly the same problem back in last skill 14 or 13 on your notes. So what was the strategy? The strategy was we are going to do a synthetic or dividing or synthetic division for this case. And if your remainder is 0, that means it is the root, and you go until remainder is not 0. So I already did the example, the synthetic division here for you. So can you guys, well, let's look at how I got that. So I'm doing, let's see, 3, dividend 3, 2, 1, 0. It is in standard form with no missing part, so I just took the coefficient, 1, 2, -1, -2, and write it here. And I'm dividing by x plus 1, so I set it equal to 0. That means I'm trying x equal -1 as my root, or my zeros, or my x-intercept. So I put -1 over here, outside of the box, and that's it. Alright, now let's actually do it. 1 comes down, multiply, -1, add it, 1. Multiply, -1, add it, negative 2. Multiply 2, added 0. Alright, so we got the remainder of 0. That means it is the multiplicity, has a multiplicity 1 at least. We don't know how many times, so we're going to keep going. So I did the synthetic division again. We're using negative 1. 1 comes out, multiply negative 1, added 0, multiply 0, added negative 2. So we got the remainder of negative 2. That means, nope, not this case. So it's only going to have a multiplicity of 1. So x plus 1 has a multiplicity 1. Do you wonder how that's related to the equation of the function? Yes, so this means if I were to factor my original problem, it's just going to be x plus 1 to the first power times, that's my divisor, times the quotient, x squared plus x minus 2 right here. If I were to ask you to factor the whole thing completely, you probably want to factor this quotient, but we're not going to do that. So once again, I try to find how many times x plus 1 is a factor or x minus 1 is a root. I did a synthetic division. I realized it only works once, meaning has a multiplicity of 1. So I just put x plus 1 to the first power times the quotient. Okay? Alright, so multiplicity of 1. Describe what happened at this root. So please see what happened at x equal negative 1. I don't know why. Negative 1 right here. What multiplicity does that look like to you around just 1? Good. So how we're going to write it? We're going to use a description we used from the previous page. The graph crosses x-axis without changing concavity at x equal negative 1. Negative 1. And now, guest teacher, please pause the video and let students work on the other 2 examples underneath it for 3 or 4 minutes, and you can start the next video and check the answer together.